welcome to the notes for Chapter 6, Lesson 1. Sorry about the blowers going here. They should take off in a minute, or they should turn off in a minute. But today we're looking at properties of exponents. So in the expression x to the nth power, x is the base, because it's the thing that we're basing all of our calculations on, and n is the exponent. So don't forget the order of operations, either PEMDAS or GEMMA, grouping, anything that's parentheses, brackets, braces, winculus, superscript, subscript, fractions, things like that. Anywhere that you could put in some form of parentheses. Exponents, including radicals and roots, since they are special types of exponents. Multiplication and or division, either from left to right, or again, turn the division into fractions and just multiply. And then finally, addition or subtraction. Pay attention to your negatives. So these are your 9 properties of exponents. Anytime you are multiplying the same base, you can just add the exponents. Since multiplication and division are opposite functions, and addition and subtraction are opposite functions, if you are dividing two of the same base, you take the top exponent and subtract the bottom exponent. When you raise a power to a new power, x to the a to the power of b, then you can multiply your exponents. On the other hand, you can sort of distribute. Anytime you have x times y, all of that to the a power, everything gets the power. The x gets the a and the y gets the a, and a z and a w and however many other pieces you've got. Doesn't matter whether you're multiplying or dividing, the same rule really applies. X over y to the a power is really x to the a over y to the a. And by the way, all of these you could go the other way around. You could take x to the a over y to the a and turn it over into x over y to the a. Negative exponents just tell you that the base is in the wrong part of a fraction, so x to the negative n equals 1 over x to the n. Similarly, if you've got something like a over, let's call this bx to the negative n, then again, the x to the negative n part, since exponents only apply to what they are most directly touching, is in the wrong part of the fraction, so it needs to move up. So ax to the n over b. Anything to the power of 0 equals 1. And then we have our rational root things. This is why radicals are technically a form of exponent. If you have, these are kind of the same rule. If anytime you have x to a fraction power, then it's really the bottom becomes the root index, the top becomes a power. And again, since roots and powers are technically the same function, you could also call this the b root of x to the a power inside. Again, the power can go inside or outside in this case. So let's take a look at some examples. So we need to simplify the following, and we'll try not to use a calculator. So we have 2x to the third to the fifth. So right now, it's really kind of looking like 2 times x to the third, and both of those are getting a fifth power. So both of those get a fifth power. 2 to the fifth power, 2 times 2 times 2 times 2 times 2 is 2, 4, 8, 16, 32. And then x to the third to the fifth, that one is using our power to a power rule, so 3 times 5 becomes x to the 15th. Part B here, we've got a power to a power and some multiplication. So the 3x doesn't really have any exponents, but it's getting multiplied by 5, which is also getting squared, and x squared, which is also getting squared. So this is really 3x times 25 times x to the fourth power. Again, power to a power. 2 times 2 is 4. And now, since 3x is really 3x to the first, x to the first times x to the fourth. Again, we're using this rule here. X to the 1 plus 4 power is going to become x to the fifth. And then 3 times 25 is 75. Part C, we've got some division, but first we're going to simplify the powers in the top. So we're going to have 6 squared over x squared squared over 12x squared. So 6 squared is 36. X, 2 times 2 is 4, raising the power to a power, so x to the 4th over 12x squared. So the first part is just 36 divided by 12, that's 3. And then because we are dividing our powers, we have x to the top minus bottom, 4 minus 2, or the whole thing is 3x squared. A couple more examples here. 5x squared times 3x to the negative 4th. So we can kind of mix and match our rules a little bit. 5 times 3 is 15, and then we have x to the 2 plus negative 4 power. 2 plus negative 4 is negative 2. But again, the negative power means that x is in the wrong part of the fraction. Technically, this is all over 1. So in order to turn that power positive, we just need to bring our x down to the bottom. So the final answer for this one is 15 over x squared. Remember, powers apply to everything that they touch. So this is technically 3 parts. It's a negative 1, a 3, and an x, but we can take care of the negative 1 and the 3 together. Remember, negative 3 times negative 3 with parentheses will become positive. The x is still getting squared. Over here, the negative 2 is getting raised to the 3rd power. X to the negative 4th is also raised to the 3rd power, and y squared is also raised to the 3rd power. So like we just said, negative 3 times negative 3 is going to be positive 9 x squared times negative 2 to the 3rd power. Negative 2 times negative 2 times negative 2. We have 3 negatives, stays negative, so that becomes negative 8. Negative 4 times 3 is negative 12. And then y squared cubed becomes 2 times 3 is y to the 6th power. Again, we're going to add our exponents for our x's right now. Also, 9 times negative 8 is negative 72. X to the 2 plus a negative 12 becomes negative 10. And then we've still got y to the 6th. And again, that x to the negative 10th power needs to move down into the bottom of a fraction. So we really have 72 y to the 6th over x to the 10th. Okay, part F here. It might be a little bit easier if we take all of those negative exponents and move them around first. So if we take this z to the negative 3rd and move it up, take the other z to the negative 3rd and move it down, we'll take y to the negative 4th and move it down, and x to the negative 3rd and move it up. Then we've got 15, x to the 2, x to the 2nd was already there, and we have x to the 3rd, so we have 3 more. 2 plus 3 becomes x to the 5th. The z's just kind of swapped places and became positive. Y to the 5 and 4 more would be y to the 9th, and then the z to the 3rd. Again, you might have already noticed that the z to the 3rds or negative 3rds could already cancel each other out. That's okay. Then the last part is 15 and 45 both divide by 15 really nicely. So if you divide those by 15, you get 1x to the 5th. You don't need to say the 1 over 3y to the 9th. So those are the straight up exponent rules. Next, we want to write these as powers in order to get an exponent. So we have 32 to the 2/5 power, which means we've really got the 5th root of 32 squared. Again, that squared can go inside or outside. 32 is really 2 to the 5th power. So we're kind of looking at this as the 5th root of 2 to the 5th power, and then the whole thing is going to get squared. So again, the 5th root and the 5th power cancel each other out, so they're really asking what's 2 squared, and 2 squared is 4. Part H here, 16 to the negative 16 to the 1/4 power. You might notice there are no parentheses in here, which means that the 1/4 power only applies to the 16. So we can turn that into negative the 4th root of 16. 16 is really 2 times 2 times 2 times 2. So that is negative the 4th root of 2 to the 4th power. And because a 4th root and a 4th power undo each other, the whole answer is negative 2. 216 to the negative 2/3 power. Well, because that's a negative power, we've really got 1 over 216 to the 2/3 power. And again, the fraction exponent is really a cube root of 216 is getting squared. 216 is really 6 to the 3rd power, so we've got the cube root of 6 cubed, and then it's going to get squared. Again, the root and the square, or the root and the cube, undo each other in this case. So we've really got 1 over 6 squared, which is 1 over 36. J, we have negative 625 to the 3/4 power with parentheses this time. So we're looking at this as the 4th root of negative 625, and that's getting cubed. Again, if you're going to put the cube on the inside, then it's still the 4th root of negative 625 cubed, since the negative is part of what has the exponent. Either way here, though, there is no solution, because you cannot take an even-numbered root of a negative number, unless you want I, the imaginary number. K here, 64 to the negative 1/6 power, should be 1 over 64 to the 1/6 power. And then we can make that 1 over the 6th root of 64 to the 1st power. 64 to the 1st power is still 64. Also, 64 is 2 to the 6th power. So we're looking at 1 over the 6th root of 2 to the 6th power. And again, the root and the power cancel each other out. So part K here is really 1/2. Part L, negative 125 to the 4/3 power, again with the parentheses, is going to be the cube root of negative 125, and the whole thing is to the 4th power. Negative 125, you can have a negative root with an odd numbered index. So negative 125 is really negative 5 to the 3rd power. So again, we can undo the root and the exponent. So we've really got negative 5 still trapped in its parentheses to the 4th power. And then a negative times a negative times a negative times a negative is an even number of negatives. So our final answer will be positive. And then 5 times 5 is 25, times another 5 is 125. Finally is 625. M is a lot like J, but ever so slightly different. Again, the parentheses are the big difference here. So we're really looking at two things here. The negative kind of stays by itself, and then the 625 to the negative 1/4 power is a separate piece. So we can call that negative 1 over 625 to the 1/4 power, or negative 1 over the 4th root of 625. And we just saw in the last example that 5 to the 4th power is 625. So we have negative 1 over the 4th root of 5 to the 4th power. Again, the root and the index, or the root and the exponent, undo each other. So this is ultimately negative 1 over 5. Part N, negative 81 to the negative 3/4 power. Again, same thing going on. The negative is not part of what has the exponent here because we had no parentheses. So again, this is negative 1 over 81 to the 3/4 power. Or we can make that negative 1 over the 4th root of 81 cubed. 81 is really 9 times 9, but 9 is really 3 times 3. So 81 can be 3 to the 4th power. Again, the 4th power and 4th root undo each other. This should be a 3. Sorry about my bad handwriting here. We've got negative 1 over 3 cubed, which becomes negative 1 over 27. Part O here, 625 over 81 to the 3/4 power. Everything in the parentheses gets the exponent, so we're looking at 625 to the 3/4 power over 81 to the 3/4 power, or again, the 4th root of 625 cubed over the 4th root of 81 cubed. Again, 625 is really 5 to the 4th. 81 is really 3 to the 4th. So we should be looking at this as 5 cubed over 3 cubed, which is 125 over 27. If you have a whole fraction where we have a negative exponent, well, that means the 16 needs to move down and the 81 needs to move up, so we can just kind of swap their places to turn this exponent positive. And now we're looking at the 81 to the 5/4 power over 16 to the 5/4 power. Or again, we could call that the 4th root of 81 to the 5th over the 4th root of 16 to the 5th. Again, 81 is 3 to the 4th power. 16 is 2 to the 4th power. So we're really looking at 3 to the 5th over 2 to the 5th. 3 to the 5th is 3. 9 times another 3 would be 27. 27 times 3 would be 81, and 81 times 3 would be 243 over 2 to the 5th power. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 would be 32. And then finally, negative 27 over 125 to the negative 4/3 power. So let's make that 125 over negative 27, all of that to the positive 4/3 power, or 125 to the 4/3 over parentheses negative 27 to the 4/3, which should really be the cube root of 125 to the 4th over the cube root of negative 27 to the 4th, or again, cube root of 125. 125 is really 5 to the 3rd power. Negative 27 with a cube root will stay negative, and it will be negative 3 to the 3rd power. Again, the whole thing to the 4th. So we're really looking at 5 to the 4th over negative 3 to the 4th with parentheses still. 5 to the 4th power is 5 times 5 is 25, times another 5 is 125, times another 5 would be 625 over negative times negative times negative times negative. That's 4 negatives, so you're going to get a positive answer in the end. 3 times 3 is 9, times another 3 is 27, times another 3 is 81.